Hey guys, good afternoon. I just wanted to do a short video here on some of the proofs between the natural logarithm and e to the x. I kind of need properties of both in order to prove each, so I'll just kind of run through both of them right now here with you. The derivative of e to the x is actually itself e to the x. So to prove that, let's write our function, y equals e to the x. I'm actually going to change that to the natural logarithm in order to derive the formula for the derivative. So if y equals e to the x, that means that the natural log of y equals x. If that doesn't make sense to you, remember that the natural log is in base e, and natural logarithms are really just exponents. The natural log of y should be equal to the value that e needs to be raised to be equal to y. Well, since e is raised to x to be equal to y, that means that the natural log of y is equal to x. So let's differentiate this. The derivative of the natural log of y is 1 over y times dy dx. I'll take the derivative of the other side. The derivative of x is also equal to 1. We're trying to find a formula for the derivative, so we need to solve for dy dx. Multiply both sides of this equation times y. In doing so, that cancels out, and dy dx is equal to 1 times y, or just y. Well, what is y equal to back from up above? Y is equal to e to the x. So more simply, the derivative of y with respect to x is equal to e to the x, replacing y with what's equal to. The derivative of e to the x is e to the x. Let's come to the second half here. I also wanted to prove the derivative of the natural log of x is equal to 1 over x. The derivative of the natural log is a rational function, 1 over x. So let's prove that formula. Y equals the natural log of x. I want to prove the formula, find the derivative of the natural log of x by writing this as an exponential function. E to the y equals x. Changing it back to an exponential, changing the log back to an exponent. Now let's differentiate this. The derivative of e to the y is e to the y times dy dx. The derivative of the inner function y with respect to x, dy dx. On the right half, the derivative of x is just 1. Now solving for dy dx, we're going to have to do here. So rather than multiply by e to the y, I need to divide by e to the y. Got to get dy dx solved for. I'm still multiplying by e to the y. So to get dy dx by itself, divide both sides by e to the y. After doing so, I get dy dx equals 1 over e to the y. Well, what is e to the y equal to? Go back up here to the previous line. E to the y is equal to x. So I can replace e to the y with what it's equal to, namely the x. And dy dx, the derivative of y with respect to x, is equal to 1 over x. We've now shown that for y equals natural log of x, its derivative of dy dx is equal to 1 over x. Each of those two proofs kind of depends on the other, but it's a good idea to look at each of them, change the log to an exponent, change the exponent to a log, and prove each from there. Thanks, guys.